This video is going to go through the solutions to the Chapter 6 test review. So we start with the first question, which should say interval notation. It says find the domain. So remember the domain, we're checking for three things. It's all real numbers or negative infinity to positive infinity, except if there's a variable in the denominator, and for that one we would set it not equal to 0. If there's a variable under the square root, and for those we set greater than or equal to 0, or the combination if there's a variable underneath the square root in the denominator, and for that we set greater than 0. So when you look at number 1, none of those are happening. There's no variable in the denominator, there's no variable in the square root, which means this is all real numbers, or negative infinity to positive infinity. Number 2, now you've got the square root. So what's underneath has to be greater than or equal to 0. So if 3 minus 5x is greater than or equal to 0, then 3 is greater than or equal to 5x, and divide by 5. 3/5 is greater than or equal to x, or x is less than or equal to 3/5. In interval notation, that's negative infinity to 3/5 with a bracket on the 3/5. Number 3 has two, or the combination of the square root and the denominator. The numerator does not matter. So the fact that that's in the bottom now means x minus 1 has to be greater than 0 and x has to be greater than 1. So it would be a parentheses on the 1 to positive infinity. For number 4, you've got two different scenarios happening. The first is the variable in the denominator underneath the root, so that would be greater than 0. The second is the numerator is also under a square root, so this has to be greater than or equal to 0. So if 2x plus 1 has to be greater than or equal to 0, 2x has to be greater than or equal to negative 1, and x has to be greater than or equal to negative 1/2. And in the denominator, 3x minus 1 has to be greater than 0, so 3x has to be greater than 1, divide by 3. And x has to be greater than 1/3. So when you go to graph this on a number line, you're going to plot that 1/3, and you're going to plot the negative 1/2. The negative 1/2 is greater than or equal to, so it's a bracket pointing to the right. And the greater than 1/3 is a parentheses pointing toward the right. And we treat this as though they're and statements, only good for where the overlap occurs, which means this is only, the domain for this is just from 1/3 to positive infinity, or x has to be greater than 1/3. Now 5 has your square root in your numerator, so again, greater than or equal to 0 on that one, and the denominator can't equal 0. So you factor this or use the even root, and then split and solve, and you get x cannot equal negative 4 or positive 4 on the number line. And in the numerator, 4x would be greater than or equal to 5, so x is greater than or equal to 5/4. And then when you plot those on the number line, you've got negative 4, you've got positive 5/4, and you've got 4. It can't equal negative 4, it can't equal positive 4, and it has to be greater than or equal to 5/4. So you are going to focus on the 5/4 greater than, but there's a hole at the 4 that I can't include the 4. So in interval notation, it looks like this: 5/4 to 4, but not including 4, so it gets a parentheses, union 4 to positive infinity. Okay, 6 says graph the function and then find domain and range. So the graph of this is going to be to the right 1 and up 3. So when all right, so I'm going to go, and it's a parabola because it's the x squared. So I'm going to go to the right 1, I'm going to go up 3, and I'm going to plot my vertex, and then I'm going to point this up. The domain on all parabolas would be negative infinity to positive infinity because those arrows point left and right. And the range, this is my lowest y, so 3 to positive infinity. Go to the next one. So 7, absolute value means it's a v. The negative on the front means it's reflected over the x-axis or upside down. The negative 3 inside says go to the right 3, and the minus 4 says go down 4. So I go to the right 3, I go down 4, and then I make it go upside down. Domain is negative infinity to positive infinity because the arrows point left and right. And my range this time goes from negative infinity up to the highest point, which the y would be negative 4. Okay, 8 is a cube root function, and the cube root function, that parent function looks like this. So the plus 3 means it's going to shift up 3. So where it normally crosses through 0, 0, it's going to cross through 0, 3. My domain is negative infinity to positive infinity because of the arrows. And the range is also negative infinity to positive infinity because it's going to keep going down and it's going to keep going up. Number 9 is your square root function. So that's that little half the parabola facing sideways. The negative is reflected over the x-axis or upside down. The plus 3 inside is left 3. The minus 4 is down 4. So left 3, down 4, and then flip it upside down. Domain, this time it doesn't go left of this point. So the domain is from negative 3 to positive infinity, which matches because it's underneath the square root. And the range is going to go from negative infinity up to that point, which is the highest y, negative 4. Okay, number 10, we're back to lines. So slope and y-intercept here. If it was just slope, you could use that negative a over b shortcut. But because it says both, you might as well get it into y equals mx plus b format. And then the m is your slope and the b is your y-intercept. So I'm going to leave the negative y, subtract the 2x, and then divide everything by negative 3. So y equals a positive 2/3 x minus 7/3, which means my slope is positive 2/3, and the y-intercept is when x is 0 and y was negative 7/3. For 11, same thing, solve for y, so divide everything by that negative 3, and I get y equals negative 4/3 x plus 5/3. So my slope is negative 4/3, and the y-intercept, when x is 0, y is 5/3, or 1 2/3. Okay, 12 and 13 are finding slope through the points. So this is your y2 minus y1 over x2 minus x1. Doesn't matter which ones you make the 1s and the 2s as long as you're consistent. So 7 minus 5 over negative 3 minus 4 becomes 2 over negative 7, or negative 2/7. 13, 7 minus 5 over 4 minus 4 is 2 over 0, which is undefined, which is consistent with this being 1, 2, 3, 4, 5, and 4, 7, a vertical line, which that slope would be undefined. All right, then the next two come from the equation. So there's 2 ways to do it. One is solve it for y. So this would be 2y equals 13, and then divide by 2, and you get y equals 13 over 2. And you should catch that there's no x, and an equation that has the same y would be horizontal, which means the slope is 0. You can also catch that from the very beginning if you notice that there's no x in this equation, and it saves you some time. When you go 15, so if you approach it the same way, look at 15, this time there's no y, which means this is an x equals equation. And if it's an x equals, where x is ever or never changing, then it's vertical and your slope is undefined. (16) says find the equation of the line through the points, and it says use point slope to solve and put final answer in standard form. So we're going to use point slope. You could actually use, if it doesn't indicate it, you could also use y equals mx plus b, but pay attention to how it's asking for the answer to be in because it says standard form. That's your x and y same side, no fractions, no decimals, and x positive. So I'm going to start by finding the slope because I need slope and a point, which you have 2 points, but you need the slope. So negative 5 minus 4 over 3 minus 2 gives us negative 9 over 1, or negative 9 for my slope. And then if I plug it into point slope, you can pick either one. I'm going to pick the first one because they're both positive. And I get y minus y1, which is 4, equals m, which is negative 9, times x minus x1, which is 2. And then distribute the negative 9. I need x to be positive, so I'm going to move the 9x to be with the y, so 9x plus y, and I'm going to add the 4 so that the constant's on the other side. And there's my equation in standard form. Number 2, this should say find the equation of a vertical line through the point 2, 7. So we know vertical means the x stays the same, so this would be x equals 2. 18 says find the equation of a line with 0 slope, which means horizontal, and if it's horizontal, it's y equals, and it would be the y of that point, which is 5. Number 19 says to graph the line. So technically there's 2 ways you could graph this. You could graph it using your intercepts if that's easy, or you could graph it by putting it into slope-intercept form. So if I do that, I'd get negative 4y equals negative 3x plus 7, and then divide both sides by negative 4. And I get y equals positive 3/4 x minus 7/4, which would be negative 1 and 3/4. So I start there on the y-axis, negative 1 and 3/4, and then I use my slope, which is 3/4. Go up 1, 2, 3, and to the right, 1, 2, 3, 4. Or you could have reversed it 1, 2, 3 to the left, 1, 2, 3, 4. So depending on, you might have like run out of room on your graph, you can always reverse those points. Okay, 20 says find the equation of a line perpendicular to this line through a point, and then put your answer in standard form. So the first thing we have to do, and the only thing you want to take from that first equation, is its slope. So shortcut here, negative a over b is negative 2 over negative 3, which is 2/3. That's the original one. Slope of a line perpendicular would be opposite reciprocal. So my slope would be a negative 3/2, and then here's my point. So if I plug it into point slope, I get y minus a negative 5 becomes plus 5 equals negative 3/2 x minus 2, y plus 5 equals, distribute negative 3/2 x plus the 2's would cancel 3. This would be 1, so negative 3 times negative 1. And then I want it in standard form, so I'm going to move the x on the side over here, so it's 3/2 x plus y, move the 5 over here by subtracting it, I get negative 2, and get rid of your fraction, so this would be 3x plus 2y equals negative 4. '21 says find the slope, the y-intercept, and the x-intercept for this line. So slope, you can solve for y, or you can do negative a over b, negative 1/3 over negative 4, which would be keep, change, flip, and I'd get positive 1/12. That's your slope. Or you solve it for y and do the same thing, get that thing attached to the x. To find the x-intercept, we're going to plug 0 in for y. So I'd get 1/3 x equals 1/4, and then multiply by 3. This is gone. X would equal 3/4. So 3/4, 0 is my x-intercept. And then to get the y-intercept, we're going to plug 0 in for x. So this is 0, negative 4y equals 1/4. Divide by negative 4, multiply by negative 1/4, and I get negative 1/16. So now my x is 0, negative 1/16. That would be your y-intercept. '22 says find symmetry and then determine if it's even, odd, or neither. So remember, if I plug in the negative x and it goes away, then it's got y-axis symmetry, which means it's even. And if I plug in the negative x and everything changes, then it's got origin symmetry and it's odd. So when you look at 22, if I plug in a negative x, I'd get negative x squared minus a negative x plus 1. This negative is going to go away because of the square. This becomes positive x plus 1. So it's not completely gone because it changed this side only. So this is none. For 23, I plug in the negative x squared, and it becomes x squared plus 4, which goes back to the original, which means this is y-axis symmetry and even. For 24, you'd get negative x to the third minus a negative x. You'd get negative x to the third plus x. Not the same, but each sign has changed, which means this is odd and symmetric to the origin. All right, 25 says graph the piecewise function and determine the function's value at the given values. So we're going to do I'm going to do the given value first. You want to do that without the graph. F of 3 would go into the category that is would be less than or equal to 3, which means I'm going to plug it into the x squared minus 1. I'd get 3 squared minus 1, or 9 minus 1, which is 8. So F of 3 is 8. And then F of 4 is in the greater than 3 range, which means we're going to use x cubed. So 4 to the third is 64, and F of 4 is 64. Now when you go to graph the piecewise function, I'm going to graph them separately and then erase. So the first one, x squared minus 1, says start at negative 1, and then it would be a parabola. I need it to be a little bit more accurate. If you go up to the right, up and out 1, you would get points from there. And then if I plugged in 2, actually I'll plug in 3 to know where it stops. I'm going to plug in 3. 3 squared minus 1 was 8. So 3, 8 is where this graph stops. And all the values less than 3 mean that it's going to come back here, and that side's going to have an arrow. And then the cubic function one is where it's greater than 3, which means it's going to start at that 3. And to graph a cubic function, we would normally start at 0, and then I would go 1, 1, like that. And if I plug in 3, I get 27. So it's all the way up here, like 3. 27 would be off this graph, obviously. And it's an open dot because it's the not or equal to here. So if you plugged in 4, you end up at 64, which means this graph is just going to increase on the right-hand side. And that's what that piecewise function would look like. Okay, 26 is asking for domain and range, and then determine whether it's increasing, decreasing, or constant. So I'm going to start with the one on the left. So let's just say this is A and B. A, my domain for this point left is here, which is -6, and it's an open dot, so it's a parentheses. And then there are point values all the way to the end of the graph, which is here, and that x value is 7. It's also an open dot, so it gets parentheses. That's domain. The range goes bottom to top. So the lowest y on my graph is here at -1. These are all solid dots, so it's going to get the bracket. And then the highest y, there's no break vertically. The highest y is here at 5, and it's an open dot, so it gets a parentheses. And then my pattern starts by rising as I move from left to right, so it's increasing first from -6 to -2. And remember, a point can be increasing, so it always gets the parentheses. Then it changes to decreasing from -2 to +2. Then it's constant with open dots from 2 to 5. And then it's increasing again from 5 to 7. For B, start with your domain. Furthest point left is this -7. It's a bracket because it's a solid dot. And then there's no break horizontally. It stops here at 9. And again, it's a solid dot. The range, the lowest y is actually here like 4.5, -4.5. And it's an open dot, so it's a parentheses. And then there's a break in between this space here, vertically, here. There's a break in that graph. So it stops at -1. It gets a solid bracket at -1. And then it starts again at 0, solid dot, so bracket, and it stops at 4, and it's an open dot, so parentheses. And then you're increasing, decreasing. It starts increasing. From -7 to -5. Then drops to decreasing. From -5 to -2. Then it becomes constant. But that first point is shared. So -2, even though it's a solid dot and it's constant, shared by the decreasing. So it's going to get a parentheses. And then it stops at 4. And that one gets a bracket because it's a stop and it's constant. Then it becomes increasing again from 1 to +7. Okay, that's the completed packet. Hopefully this helps you prepare for your test.